In this video, we are going to discuss about agents. What is an agent? An agent is anything that perceives its environment through sensors and acting upon the environment through actuators. Actually, it's a program that observes the environment and take the necessary action. Okay. Example, human is also an agent, a robot, and a thermostat detecting room temperature, and then fire alarm. You can have agent in this kind of activities. Then agent function and program. Agent's behavior is mathematically described by agent function and function mapping any given percept sequence to an actions. In practical, you can say it's a program for real-time implementation. So agent program here, it's going to observe the environment through sensors. This is agent. Okay, it's a system with agent program. We can say like that. Here we have sensors. It's keep on observing the environment through sensors, perceive the information from the environment, and based on it, it's going to take the necessary action. For example, uh, fire alarm or smoke detection. In this case, the agent is keep on watching that room temperature that perceive the environment through sensors, and if the temperature level is going beyond that threshold level, then it's taking necessary action. Action may be alerting the house owner or giving alarm like that. So here we have actuators for taking necessary action. So here you can simply say that a system with agent program can monitor this kind of things. So structure of intelligent agents, AI designs the agent program, then the program runs on some kind of architecture. To design the agent program, we need to understand the perceptions, actions, goals and environment. Perceptions perceive the information from the environment, taking necessary action if it goes beyond that threshold value. The goal may be for fire alarm or what purpose it is being designed. Then environment, maybe the room temperature or weather monitoring. So in where it's going to be placed. So diagram of an agent. Here we have this agent program. It's a system with agent program. Then it's having sensors for perceiving the information from the environment. Keep on watching this, collecting information from the environment through sensors. Then if necessary action it has to take for the given value, through actuators it is going to perform. Here sometimes we can say that only with software, okay, no hardware is involved. So example, the flight simulator, video games, internet. Okay, here those are having only this software. All parts of agents are having software. It's called soft parts of software agent. Then vacuum cleaner world. Here we can go for having this agent in the vacuum cleaner. It's for perceiving the information. The sensor is going to check whether there's a dirt or not. Then, so perception is clear or dirt. If vacuum cleaner is placed in the style A, it's going to check whether there's a dirt or not. It's a perception. If there's a dirt, then it has to suck or clean this one. Then, otherwise there's no dirt, it can move to the left. Suppose this vacuum cleaner is placed in B, then it will go to this A or do nothing. These are the possible actions it can perform. So real world example here, automated taxi driver. The automated taxi driver, we can have see this performance measures, environment, actuators and sensors. Okay, here the performance measures, how do you say that the automated taxi driver is good? The driverless car. The Tesla is trying this kind of cars. So this kind of real world problems, performance can be measured. How it is safe, fast, whether it has been driving the car legally, comfortable trip for the passengers. Then what about the profit? Then where it is going to be operated, the roads, traffic may be used by the customers. Actuators may be steering wheels, accelerator, brake, signal, horn. Then sensing the information, passing the information of the environment through cameras, sensor, speedometer, GPS, like this. So these are four factors. It's called PEAS. Performance measures, environment, actuators and sensors for automated taxi driver. What is rationality and rational agent? Rationality in the sense states of being reasonable, sensible, and having good sense about the judgment. Suppose it's taking necessary action. How do we believe that it's taking the correct action? So it has to go for some judgment. Only because of this data, example, when it's giving the fire alarm. Okay, how do we say that the machine is giving the fire alarm? With correct scenario. Because of this heat of that particular room is moving above that threshold value, that time it's going to give the alarm. Okay, so it has to give the judgment like this. Okay, so rationality is nothing but it's reasonable, sensible, and having sense of the judgment. Okay, so performing action with the aim of obtaining useful information is an important part of the rationality. Then rational agent is nothing but which is capable of doing expected actions to maximize its performance measures on the basis of perceived experience and built-in knowledge base. It's having some prior information about it. Using this one, it's going to take the necessary action. So the rationality agent depends upon this performance measures, perceived sequence, prior knowledge about the environment, and actions. With this, we can say that it's going to perform the right actions. Then, rational agent in the sense one that does the right thing. The judgment is right. The criteria based on the performance measures. Example, web search engine, tic-tac-toe player, chess player. Okay. So, how does performance is measured play a role? Maybe a short term or long term. So, the rational agent one does the right thing and every entry in this agent program whatever it's doing it's correct. The sense we are proceeding. Then task environments already we discussed the PEAS are task environment, the performance environment actuators and sensors. Okay, here the rational agents can be measured using this four. Example we discussed automatic taxi driver. Then the performance measures. How can we judge the automated driver getting the correct destinations, minimizing the fuel consumptions, minimizing the trip time and cost, minimizing violations of traffic laws, maximizing the safety and comfort. Then environment may be with variety of roads, traffic lights, other vehicles. Then interaction with the customers. Then actuators. They have to operate these machines like accelerator, steering, brake. Okay. Then sensors is perceiving information through GPS systems or cameras. So this is about PAs of automated taxi driver. So the task environment that includes these things. Performance measures, safe, fast, legal, environments, roads, actuators, the machines, sensors, the cameras or GPS systems. So here, what are the properties of task environments? Maybe the fully observable or partially observable. If an agent sensor give it access to the complete state of the environment, then you can say it's fully observable. The sensor detects all the aspects. We can say fully observable. Then partially observable in the sense only few points going to be observed. Example vacuum cleaner in that agent program. Then second property of task environment is deterministic or stochastic. The next state of environment completely determined by the current state. If in the particular state, it's going to say the next state, it's called deterministic. Otherwise, it is stochastic. Then episodic or sequential. Episodic in the sense agent single pair of perception and action. That means every episode is independent of each other. It's not depends on the previous episode. But sequential, it's based on that previous action. The current action may affect all the future decisions. Or the next one is about static or dynamic task environments. The dynamic environment is always keep on changing over the time. Okay. The number of people in the street, it's not static. Keep on changing. Semi-dynamic in the sense environment is not changed over the time, but it will change. Then another property of this task environment is discrete or continuous. If there are limited number of distinct states, clearly defined perceptions and actions, environment is discrete. Example chess game. Then continuous example is taxi. Then next one is about single agent versus multi-agent. The playing crossword puzzle, we need only single agent. Single program is enough. But chess playing, two agents, like that you can go for. Based on the problem, maybe a single or multiple agents. And the next property is known or unknown. The distinction refers not to the environment itself, but the agent's state of knowledge about the environment. In known environment, the outcomes for all the actions are given. Environment is not known, the agent will have to learn how it works in order to make good decisions. Then the example for task environments here, we have observable or non-observable, deterministic or stochastic, episodic or sequential, static or dynamic, discrete or continuous, single or multi-agent for various applications like crossword puzzles or chess, other games, taxi driving. Okay. Thank you.